Hello students, Callie Daniels here. In this video, we will solve equations with rational expressions. In example 1, let's identify each of the following as an expression or an equation, then simplify the expression or solve the equation. Now, part A is definitely an expression. We see numbers and symbols and a variable that is x, but no equal sign. This is an expression, and we will simplify it. We'll simplify by performing the given operation. So we're going to add 4/7 x to 3/5, adding coefficients. We need a common denominator of 35. So let's multiply 4/7 by 5/5. And let's multiply that coefficient 3/5 by 7/7. This gives 20/35 x plus 21/35 x. 20 plus 21, that's 41/35 x. All we can do with an expression is perform the indicated operation and or simplify it. Okay, simplifying, we would reduce this if we could, but we can't, so we won't. All right, this is in its simplified form. Part B, this is an equation. We know that because we see an equal symbol and an expression on each side. And what do we do with an equation? We solve it. We solve it for x in this case. Now, for equations, we can use our properties of equality. As long as we perform the same operation on both sides, we're pretty much good to go. Now, our LCD of the fractions that we see is 10. I'm going to choose to multiply each side by that LCD 10. Now, as we multiply each side by the LCD, you want to multiply every term on both sides by that LCD. In this case, 10. So don't forget on the right to multiply 10 times 1. Now we multiply by the LCD so we can divide out those denominators. 5 divides into 10 2 times. 2 times 3 is 6 over 1. That's 6 as our coefficient of x. Looking at our next term, 10 divides into itself 1 time. Okay, and that 1 times 7 is 7, and there's our coefficient of x. On the right, 10 times 1 is 10. So we've multiplied by the LCD and we've eliminated denominators. Yay! Okay, no more fractions. This is cool. Makes our work easier, doesn't it? 6 minus 7 is -1, x equal 10. Multiply each side by -1 to obtain x equal -10. So we would say that the solution set to this equation is the number -10. Now let's notice uses of the least common denominator, LCD. When we are adding or subtracting rational expressions, we have to keep the LCD throughout the simplification, as we saw in example 1a. Our LCD is 35, so we built up fractions to obtain that LCD, and notice that it remains. When solving an equation with terms that are rational expressions, multiply each side by the LCD so that denominators are eliminated. As in example 1b, our LCD was 10. We multiplied every term on both sides by 10 and divided out those denominators, okay, eliminating fractions. And then we solved the resulting equation. Okay, so keep in mind, we simplify expressions, we solve equations, and we generally can recognize those equations because we see an equal symbol in there. Now for the rest of our time in this video, we're going to solve some equations with rational expressions. And our steps are: step 1, multiply each side of the equation by the LCD. This clears the equation of fractions, and be sure to distribute to every term on both sides of the equation. Step 2, just solve the resulting equation for proposed solutions. And lastly, in step 3, check each proposed solution by substituting it into the original equation. Reject any values that cause a denominator to equal 0. In example 2, we'll solve each equation and check the solutions. Now in part A, we've got an equation with fractions, rational expressions, and we're going to multiply each side by the LCD, which is 12. So I'm going to take 12 times the left. That's equal to 12 times the right. And notice I've written 12 as 12 over 1, just so I can see that that's in the numerator. Now let's divide before multiplying. 4 divides into itself once and into 12 3 times. On the right-hand side, 3 divides into itself once and into 12 4 times. This gives 3 times z minus 1 is equal to 4 times z plus 3. Now you might have initially looked at this equation and said, hey, that's a proportion. It's a fraction set equal to a fraction, and can't I just cross multiply? Yes, you may. And notice that if we do cross multiply, 3 times z minus 1 is what we have on the left side at step 3. 4 times z plus 3, we see that on the right-hand side, don't we? Now you can only cross multiply when you have a single fraction set equal to a single fraction, okay? Or just multiply by the LCD. Well, let's solve. Distributing on the left, we obtain 3z minus 3. On the right, that's 4z plus 12. If we subtract 3z from each side and subtract 12 from each side, we obtain z is equal to negative 15. Just a quick check of that. Make sure you go in your original equation. Negative 15 minus 1 over 4, is that equal to negative 15 plus 3 over 3? Is negative 16 fourths equal to negative 12 thirds? Yes, negative 4 is equal to negative 4, and this checks out fine. In part B, solving this equation, we're going to multiply through by the LCD, which contains every factor that we see here. We see 4 and x. Now, another thing to note is that we cannot allow x to be 0 because division by 0 is undefined. So I'm just going to make a note of that right off the bat for myself here. Let's multiply every term on both sides by the LCD 4x. I'm going to write this 4x over 1 times 5 minus x over x plus 4x over 1 times 3 fourths is equal to 4x over 1 times 7 over x. Now let's divide out common factors, divide our x's, divide the 4's, divide out the x's, and let's see what we have here. Distributing 4 times 5, that's 20 minus 4x plus 3x is equal to 28. Combining like terms, we have negative x. I'm going to subtract 20. Negative x is 8. In other words, x equal negative 8. This is our proposed solution. I notice that it does not cause a 0 in the denominator because only x equals 0 would do that. And a quick check here. In your original equation is 5 minus negative 8 divided by negative 8 plus 3/4 equal to 7 divided by negative 8. In other words, is negative 13/8 plus 6/8, 3/4 is equivalent to 6/8, equal to negative 7/8. Yes, it is. That checks out just fine, and our solution set is indeed negative 8. As we continue with example 2, part C, still solving each equation and checking solutions. We're going to multiply here by the LCD P minus 2. I'm going to tell myself here very quickly that in the denominator we cannot include P equal 2. P cannot equal 2 because 2 minus 2 is 0 and would cause 0 in the denominator. So just FYI. Now as we multiply each term on both sides by P minus 2, P minus 2 times P over P minus 2 plus 4 times P minus 2. Multiplication is commutative. The order doesn't matter there. That's equal to P minus 2 times 2 over P minus 2. And let's divide those denominators. What does that leave? P plus 4P minus 8 is equal to 2. Combining like terms, 5P. Let's add 8 to the other side. Divide by 5 to obtain P equal 2, but we made a note to ourselves above that P cannot equal 2 because if it is, then we have 2 minus 2 or 0 in the denominator in a couple of places. This was our proposed solution, but it does not check. Therefore, we say that there is no solution. Or you might identify that by saying that the solution set is the empty set, and that is the empty set symbol, meaning no solution. Now, part D. I'm going to go ahead and factor here. That factors x plus 3, x minus 1. Our LCD is every factor that we see. And we see the factor x plus 3 and the factor x minus 1. I'm going to make a quick note to myself that x cannot equal 1 because 1 minus 1 is 0. That's a 0 denominator. And x cannot equal negative 3. So in the end, if either of those is a proposed solution, we will omit it. Now let's multiply each term by x plus 3, x minus 1. Every term on both sides. Yeah, this takes a lot of writing, doesn't it? But we're really going to love this next step. It's worth it. Okay, here we go. Have some fun. Let's divide those denominators. We do this step so we can eliminate the fractions, don't we? Gone, gone. All right, what do we have? We've got 1 times x plus 3, or x plus 3. Now, in the middle here, we've got, you can think of that as negative 1, okay, times 2. Let's write that as negative 2 times x minus 1, and we'll distribute as at our next step. That's equal to x squared plus 3x. X plus 3, distributing minus 2x plus 2, equal x squared plus 3x. Combining like terms on the left, that's negative x plus 5, equal x squared plus 3x. This is a quadratic equation, so let's write it in standard form. I'm going to move terms to the right so that the coefficient of x squared can remain positive. 3x plus x is 4x. Subtract your 5, that's equal to 0. This trinomial factors x plus 5 times x minus 1. 0 factor property, x plus 5 is 0, or x minus 1 is 0, giving x equal negative 5 or x equal 1. X cannot equal 1 though, can it? Because 1 causes a 0 denominator, division by 0 undefined. Okay, we're not going to check this one, but the negative 5 does check in your original equation. Therefore, the solution set for this equation is negative 5. X equal 1 we call an extraneous solution. We did everything correctly. We found 2 proposed solutions, but that one does not work. Causes a 0 denominator. It is extraneous. Example 3, and then we're done. Solve each formula for the specified variable. All right, here we're solving for t, so let's multiply each side by v, the denominator, so that we can divide that denominator. This gives Vp equal Kt. This is Boyle's law for relating temperature, volume, and pressure, by the way. Last step, divide each side by K. Temperature is equal to volume times pressure divided by some constant, given the gas you're working with. In part B, we're going to solve for Q. Let's first multiply by the LCD KPQ. Each term, both sides. KPQ times 3 over K equal KPQ times 1 over P plus KPQ times 1 over Q. Divide your common factors, which is going to eliminate denominators. This gives 3PQ equal, let's see, that's KQ plus KP. Keep in mind we're solving for Q. We see that in 2 terms. I'm going to subtract KQ so that we can at least get our K terms on the same side. Now these terms are not alike and we cannot subtract them, but we can factor Q out. Q times 3P minus K equal KP. Last step, we can solve for Q by dividing by 3P minus K. Q is equal to KP over 3P minus K. There we've solved formulas for a specified variable, and in this video we have solved equations that involve rational expressions. Good luck on these exercises.